the object, real and inverted. Beyond C, position of image between focus and center of curvature, and the image is diminished. You can see this case. When we place the object beyond C. Mhm. Here we have placed the object beyond C and we get the real and inverted image because this is on the same side of the front side of the mirror and image is diminished. From here you can see or from here you can see. This is just a reminder for you. Okay, when we place when the object is at infinity, means rays are coming from the infinity, and we got the image at the focus, means focus here the image is at focus now. This is focal plane I have told you. So we got the image at focus, and in this case also the image is real and inverted. Here is the only case when the image is virtual and erect, and that is when we place the object within focus, or we can say between pole and focus in front of the concave mirror. So
Yes.
this is all about the concave, the story of concave mirror image formation. And so now we will move towards the numerical portion, and for that we should know the sign convention. Okay, and I am writing some of the uses of concave mirror. Okay, there are some uses of concave mirror I am writing. So uses of concave mirror. Uses of concave mirror. Number one, you can write shaping mirror. Shaving mirror. Okay, and shaving mirror again you can say used as a reflector in torch. Concave dishes is like third point. Concave dish antenna, like TV dish antenna. And one more point I am adding. Doctor's head mirror. These are some of the uses. You can note it down, and after that we will use the most important topic, sign convention and nomenclature.
Okay.
This is the topic. Noted?
No, sir.
When completed, please tell me.
Done, sir.
So please concentrate your mind now. And this is a concave mirror, and this is also a spherical mirror. Okay. So I am writing first for concave mirror. Concave. And this is the principal axis. This line is the principal axis.
Yes, sir.
This line is principal axis, and this point is pole. This point is pole. This point is center of this mirror is pole. Okay. And this is the front side of the mirror. This is the front side now. This is the
Yes.
front side. This is the back side. Why this is the back side of the mirror? Because the coated side is back side. So here I am writing this is front, this is back. Okay. Light will come always from the front side. Okay.
Yes.
For the image formation, light will always come from the front side. It means that you can say object, we always place the object in front of the mirror.
Yes.
We can like you can see that in your home there is a mirror, plain mirror, and you are always in front of the mirror if you want to see yourself. Okay.
Yes.
Okay, so that's fine. So if uh, means the direction of light will be always like this. Okay.
Yes.
Always like this means light can move in this direction also. Object can give the light in this direction also, but now here I am considering that the direction of light is in this direction, means light is falling on this mirror from any object, and I am supposing the object is like this is the object, not like this. This is the object. This is object O. And this object is placed in front of the mirror. This object is placed in front of the mirror, and this is the light ray. Direction of light means light is going in this direction. Light ray, or you can say direction of light ray. This is the light ray, and light ray is going in this direction. And this is the object. This is your object. And obviously this light ray will be from any light source, means this light ray will be from the object. So the first point is in sign convention, all distances are measured from pole. All the distances will be measured from the pole. You will measure the distance from the pole. Like here you can do this. If you want to calculate the distance, what you will do, if you want to measure the distance between the object and the mirror, you will go in this direction now.
Yes, sir.
From the pole, always you have to move from the pole to the image or to the object. Okay, so I am measuring this distance like this. Okay, this is the distance. This is the distance, and this distance is is small u. Is small u. Okay, I will represent what is small u is known as. Small u is known as the distance of object from the mirror. Distance of object from the mirror. Small u. Okay, so this distance, if we are measuring distance in this direction and light is going in this direction, means this distance, object distance, should be negative. After this point, this will be clear. Distance measured in the direction of light is considered as positive. So this distance we are measuring in the opposite direction of light, so this distance should be negative. And third point is distance measured in the direction of light is considered as not position, positive. In the direction of, you should write incident light. In the direction of incident light. considered as positive. This is light ray, incident light ray. Okay, I'm writing here incident ray. This is incident light. And third point is you can write distance measured in the opposite direction of incident light is considered as negative. We are measuring this distance in this direction and light is going in this direction, incident ray is in this direction. So this distance should be negative. Okay, and fourth point is the object is placed on the principal axis. Object is placed on the principal axis perpendicular to the principal axis in the upward direction. In the upward direction means object is not here inward. Object is placed as erect.
Yes.
Okay. So for the object distance, for the height of the object, this is the height of the object. This is the object and this object have some height. Okay. Okay, this is hi. Okay, this is hi. This distance from here to here is not hi, this is ho. This is ho. This distance is h. This height is height of object. Distance is measured upward perpendicular to principal axis. I am writing principal axis like this. Is positive. You will take the distance positive. Fifth point is distance measured downward perpendicular to is negative. These things will be more clear when we will solve the numerical. So here you can see that I need some space. Now here this if you are measuring the distance in this direction, means if you are measuring the distance in this direction, this distance will be negative distance. Negative distances, you can say. And if you are measuring the distances in this direction, this is the line perpendicular to the principal axis. If you will measure the distance in this direction, like if you, for example, you can say, here is the image of the object. This is the image of the object. And for measuring the distance of image from the mirror, you should move from pole to this image. Okay, pole to this image. Pole to this image. Means you have to move from pole to the image, and this is known as V. V is the image distance. So we are measuring distance in this direction. We are going in this direction. So the distance, this image distance should be positive for this case, because we are going in the same direction of incident light. Okay. So if you are measuring distance in this direction, means distance will be positive distances. Don't be confused. Positive distances. Okay. And for the image, this distance will be positive because this is, we are measuring the distance from the principal axis and we are going in upward direction. So the height of the image, this is height of image. HI. So I am writing all the terms. I am writing all the terms in corner. U is object distance. Object distance. V is image distance. And always I am taking the distances from the pole. And HI is height of image. HO is height of O for object. This is object. This is image. And O for object and I for image. And you are measuring the distance in this direction, means this height will be positive. This height will again be positive. If the height is like this, if the height is like this, means the image is like this. So this height will be negative. Okay, this height will be negative. This height is positive. This height is again positive. This distance is negative. This distance is the distance V. This is positive. Okay, please note it down. Don't confuse in these things. Try to we will solve numerical, then you will get into it. Azaan, are you writing?
Yes, sir.
Okay.
Sir, can you scroll down?
When completed, please tell me. Done. Okay. So if the object is here, means if the object is in front of the mirror, you can say in another way, then the distance of the object from the pole will be negative. We will see in the numerator. No problem. And now mirror formula. Mirror formula. Mirror formula is the 1 upon f equal to 1 upon v plus 1 upon u. This is the mirror formula. Very, very important formula. Please learn this formula. Here f is the focal length of mirror. Focal length of mirror. Whether it is concave or convex. V is the distance of image from pole. Distance of image from pole. U is the distance of object from pole. And if you have a concave mirror, then your focal length will always be negative. Okay, if you have a convex mirror, we will discuss convex mirror later. We have discussed this also, negative.
Yes, sir.
Yeah. So please note it down.
Okay.
Very, very important formula for solving the numericals. Remember that U is the object distance from the pole, V is the image distance from the pole, F is the focal length of mirror. Here in this chapter, the numerical is the game of sign convention. Means all can apply the formula very easily, but they got problem when they put the values with sign. Sometimes they take u with positive, sometimes they take u with negative. And completed, Azaan?
Yes, sir.
So there is one more term, linear magnification. Linear magnification. Linear magnification tells us the ratio of size of image to the size of object. Okay. Linear magnification is the ratio of, you can say, height of image. Height of image to height of object. And this linear magnification is represented by m. This m is equal to hi divided by ho, and this is also equal to minus v by u. This is also very important, very important formula. Where hi is the height of image. Height of image, or you can say size of image.
Okay.
And ho is the height of object, or you can say size of object. Please note it down. Now we will use all these things in the numerical. And we will take all the distances with sign. We will put all the distances in the formula with sign.
Okay.
Completed?
No, sir. One.
Okay.
Done.
Okay. Then. So we will solve one numerical. Find the we have to find the size means height of the image, nature of the image, and position of the image. Position of the image means V. So,
Okay.
and always try to draw the diagram of the question. This is the mirror, concave mirror. And this is principal axis. You can draw the rough diagram, and object is placed here, somewhere here at a distance of 15 centimeter. This distance is 15 centimeter and 15 centimeter. So we have u is equal to 15 centimeter, and this u is in front of the mirror. This u is in front of the mirror, so we will take the negative sign. Means light will go in this direction from this object, and we are measuring the distance in this direction. So
Okay.
u is negative.
Yes, sir.
But why I am saying u is negative? Simply you can say the object is in, if the object is in front of the mirror, the object is always in front of the mirror. If we want to find the image, if we want to form the image, okay, so you will take the distance in negative, means u equal to minus 15 centimeter,
Okay,
and
sir.
this object is placed like this, size of size 1 centimeter, object size given, an object is placed like this, so placed like this is height of object given, this will be positive. Why this is positive? Because object is placed like this, 1 centimeter. Always take the object like this, okay,
Okay, sir.
means you will always place the object in front of the mirror. You are going in front of the mirror, and you will always up erect, your position will be erect. You will not stand in front of the mirror like this. If your head
Yes,
is like this, you will always be in the mirror like this, okay.
yes, sir.
If mentioned in the question, the object is placed vertically downward from the principal axis, then only you can take the negative height of object, then you can take on the negative. And I have told you focal length is given, and this is concave mirror, so focal length of concave mirror is always negative,
Negative.
10 centimeter. And we have to find the size, nature, and position. So we have formula. First we will find the position. For the position, we have this formula 1 by f, 1 by v. We have to find this v, 1 by u. Take all the things with sign. This will become minus 1 by 10. Okay.
Okay.
This is 1 by v. And what about 1 by u? This is plus, and this will become minus. What is the value of?
1 by 15.
Have you understood now?
Yes, sir. Yes.
This is just a very easy calculation. So I will take here minus 1 by 10. Oh, sorry, minus 1 by 15.
15.
If I solve this, I will get 1 by v is equal to
1 by f minus 1 by e.
If this will be like this, so this will become 1 by 15. 1 by 15 minus 1 by 10. This LCM of this will be 30. This will be 3. This will be minus 1 by 30. Do you know these kinds of calculations?
Yes, sir.
So 1 by v is come out to be minus 1 by 30. So v is minus 30 centimeter. V is minus 30 centimeter. So position of image is minus 30 centimeter, and v is negative. V is negative. So when the negative distance came,
Sir,
when
I have one question, sir.
okay.
Sir, can you scroll down? Sir, in the 1 by 15 minus 1 by 10, we can cross multiply also, right?
Yeah. Actually,
10 minus 15 by 150. We can do that also.
yeah, dot that also you can do. I am doing that, but
Okay.
that is too lengthy. This is 150.
Yes.
You will multiply this with this, and you will write like 10 minus 15. This will be minus 5 by 150, and this will be minus 1 by. You can do as you want. I have done this because this is easy. So image distance is negative. Here the distance of image comes out to be negative. So from here you can say position of image, same sides, or you can say in front of the mirror.
Okay, sir.
Why I am saying this? Because the distance, image distance is in front of image will form in front of mirror at a distance of 30 centimeter. So I am drawing this in the diagram. Suppose this is 15 centimeter and this is the principal axis. So image is forming here, but we don't know the image will be in upward direction or in downward direction. But we know that the image is at a distance of 30 centimeter from the pole in the same direction. So for that, we have one formula of magnification. We have magnification is equal to height of image, height of object is equal to minus v by u. Okay, we do not have height of image. We have height of object 1 centimeter. This is minus and v is minus 30.
30 by 1.
What is u? U is minus 15.
Yes.
This and this cancel out. This will become 2.
Minus 2 it will become.
This will become 2 and multiply by minus, this will become minus 2. So height of image is come out to be minus 2 centimeter. So height of image is negative. So image is inverted. Okay. Inverted. So from here you can you can say one thing more. As the image is on the same side of object or in front of the mirror, so you can say the image is real. The image is real. So here you can write real image because the image is formed in front of the mirror. So now I am finally drawing the diagram. So image is formed somewhere here in the downward direction. Why I am taking the downward direction? Because height is negative and the distance of this image is, this is at a distance of, this is image, this is object, this is at a distance of 30 centimeter. And please remember one thing, this is inverted. So first question was the size of image. So size of image is 2 centimeter.
Yes.
So you can write here size equal to 2 centimeter. You are writing all the things for image. And another thing was nature. Nature is real and inverted. You can guess this from this also. The image is inverted means the image will be real. Okay.
Okay.
And another thing is position. So position is in front of mirror.
Yes.
In front of mirror at a distance of 30 centimeter from pole. Okay. And we will solve more numericals in the next class. More numericals.
Okay.
So from where do you want to note?
Yes.
Do you want to note this now?
Yes.
Okay, please note. Be careful with sign. The object is placed in front of the mirror at a distance of 15 centimeters. So I have taken u is equal to minus 15. Height of image is 1 positive, and image distance is 30 centimeter in front of the mirror. In front of the mirror is negative in this case.
Fine, sir.
Scroll down.
Okay.
Should I scroll down?
Yes, sir.
Have you completed this or you are just writing?
Writing, sir.
Okay, please write. Sorry.
Done.
Done. And this one,
Yes, sir. This one.
you are writing this now?
No, sir.
You have completed this all?
No, sir. Just nature and position.
This now? You have to write this.
Yes.
Okay, please write. Completed now, Azaan?
Sir, just one, sir. Done.
Okay, Azaan, now you can leave the meeting. Okay, thank you.
Thank you.
Hello, Nawal.
Hello, sir.
Hello, how are you?
I'm fine, sir.
Okay. So in the last class, we have discussed the series combination of capacitors.